Good morning, everybody. Welcome to this webinar that we will be conducting here. It will be a 30 minutes webinar. You can push forward, Pius.
Thank you. My Icelandic is really bad, so Jorte, please tell me what's on this slide.
Yeah, this is simply our agenda today. First, we are holding this together, Vegna and Plant Health Cure in the Netherlands. And our objective today is to educate on organic farming methods for all kinds of growers. And another objective for us is to supply organic fertilizer and mycorrhiza for certified growers, organic growers, and traditional growers. We will be talking about plant diseases today and how to avoid them. That will be the bulk of the presentations. Then we will have questions and answers like last time. Then we will, Pius, you will present Theirra Plus, one of your products. And we will briefly go over our next webinars. This webinar is recorded and will be shared on our YouTube channel. And this will be in English and Icelandic. You can ask questions in Icelandic as well. So take it away, Pius.
Thank you very much for this introduction, Jorte. I'm very pleased to be able to give you this second webinar in a series of 8, I believe, for the coming period, every second Tuesday. And let's start to take off. Plant diseases. If we talk about plant diseases, then we have to see where we came from. Because in modern agriculture, like we have today, we fight diseases. We fight, we spray, we see symptoms, and we suppress symptoms. But the real thing is, we should be asking, why is that plant attacked? Why is it getting sick? Could it have to do with the conditions? Because plants have been living on this earth for 450 million years. And there's differences. They cannot run away from danger. They are rooted in the ground, they are anchored in the ground. So they had to develop different way of defending themselves. Like people, we have adaptive immunity systems. But for plants, this is really useless because they cannot run, they cannot hide. So they make different, they have different systems to respond to attacks. And they make these decisions at the moment of attack. So basically, action is reaction. That's really basic for plants. So if a plant is never hurt, then it will not be able to attack itself, to defend itself. Unlike people, plants don't have an adaptive immune system. I don't want to make it complicated, but plants basically react to the action. Insect attacks the plant will respond by giving a reaction, a chemical reaction from the inside by producing jasmonic acid, salicylic acids, etc. So they can fend off fungi and bacteria and insects from the outside, from the inside out. Because plants really, they can grow on the strangest places and they grow everywhere. Unbelievable where plants can grow, on the top of towers and in the deserts. So what is it that they can do this? In my presentation of, hang on, I have to move a little, from 2 weeks ago, I talked about mineral nutrition. But how can we expect plants to be resistant to diseases if we keep going in the current understanding of plant food? What is that? What you see on the slide is, of course, that's food for us. It will make us grow, but will it keep us healthy? And that's one of the major problems that we have in agriculture today. One of the biggest problems is that we still foresee that plants need only a certain amount of minerals. And a certain amount of minerals is counted in our law of the minimum, as we call it, with 17 elements. I have to scroll through here. Sorry for that. But if you look at all the stresses that plants can have, biotic stresses and abiotic stresses. So the biotic stresses are the really pathogens and the insects and the herbivores that literally attack the plants. But they need a signal to be able to attack that plant. And it's really important how that plant reacts to that. For instance, if you look at the abiotic stresses like heat, cold, drought, we call them abiotic stresses. But the problem is that these abiotic stresses are most of the times caused by biotic stresses, by insect attacks, by spraying pesticides on the plants. For isn't it a bit strange that plants in nature would be stressed from water, would be stressed from cold? They have this intrinsic system to cope with these problems. So basically, if we talk about all these stresses, why don't we take a look at, and now it's freezing again. I don't know why. My screen is freezing. There it is again, sorry. Basically, it's undernourishment, or what we call mineral deficiencies. So are plants suited to defend themselves? Do they eat normally? Or maybe I should say, can you really expect plants to grow healthy and stay healthy if they eat hamburgers and French fries all day, every day? And that's my main concern when it comes to plant diseases and the plant natural defense systems. Because plants can produce gibberellins, auxins, ethylene, jasmonic acid, silicic acid. They can produce so many hormones that actually defend the plant. We call them elicitors, and they are there to help the plant defend itself. And this picture shows you what is happening inside the leaves. And inside the leaves means also, if you can follow my arrow, this is the cell wall and this is the cell content. And you see how important it is that calcium is able to reach into the cell. And many of the minerals that we use nowadays, they are given in too much or too little, but not balanced, because we work with plants in a way that we feed them with synthetic fertilizers and we expect them to stay healthy. and I talked about it last time in my presentation. Plants need more elements. So how can they stay healthy if they don't get the right food? And what makes them healthy is a balanced food system for plants, a balanced food system based on the fact that they can respond. Why do I show this calcium channel here? These calcium channels, they're really, really important in switching on the genes. But if you give too much kalium, like too much salt, then these calcium channels, they will be closed. They will be closed because of the pressure from the cells among each other. And the cell pressure makes calcium channels to be closed, so calcium is not able to switch on the defense genes. And that's a very simplified action here. And how can you see that? How can you see that for yourself? Well, if you take, and I hope you know what a refractometer is, or it's called the Briggs meter. That is basically a glass prism, and you put a drop of liquid from the plant sap, from the stems or from the leaves, or you can do it with fruit. Then you can measure by the breaking of the light, you can measure actually the value of sugars, but not only sugars, dissolved mineral substances. What you see is the light breaking of dissolved substances, or you call it fertilizers or minerals or whatever. If you see a very sharp line, then the light is broken in a less diffuse way. That means there's very little dissolved products, dissolved solids. Let me put it that way, dissolved solids. If you take here a look, then you can see a very, very slight discoloring here around 14. There's two things. The blurred line, that means that there is more dissolved solids, so the light is spread more over the prism. And if you have a more spread light, you can see there's more dissolved solids. Now, this is an onion from conventional farming. It has a Briggs value of 7. That is fairly low. It's almost a guarantee that this plant will be attacked by fungi and insects. It's almost a guarantee. This is an organic onion. That plant was grown with mycorrhizae and organic fertilizers and the right soil biology. You see here a line of 14. That means this plant is really healthy, because a lot of science has proven plants that have a Briggs level over 12, they won't get attacked. The concentration of dissolved solids is too high for fungi or insects or bacteria to attack that plant. You will recognize it, because you all know this little apple in your fruit basket at home that nobody wants because there was a spot on it. And that apple is sitting there in that fruit basket. It's sitting there and it's sitting there and nobody wants it. And the apple starts shrinking and it gets wrinkly. And then at the end of the day, you make something out of it or you throw it out, because nobody wanted that apple because it's all wrinkled. But it was not a matter of rotting. No, it was a matter of concentration of sugars that avoided any damage and any rotting process in that apple. And that's why it's drying out. And it can sit on your fruit basket forever. It becomes drier and drier, and the concentration of sugars gets higher and higher. Therefore, these dried apples, they won't be attacked by fungi or bacteria or insects because the concentration of solids is too high. A Brix value, there's a lot of literature on the internet. If a Brix value raises above 12, your plants are totally safe. And if we talk about plant health in the very big picture, and the very big picture is like what really big companies like Syngenta and Bayer are doing, they make their studies and they ask themselves, why can't we reach full potential of plant growth? If you look at, excuse me, if you look at these numbers, the green lines are what you can get from your plants without crop protection, they call it. I call it without the use of pesticides. They call it crop protection. And then you can reach these numbers. With crop protection or with the use of pesticides, you will fight off diseases. So this is your complete harvest. But what about that yellow? Why cannot we reach that yellow phase there? We call it a loss due to biotic and abiotic factors, diseases, problems, bad weather, drought conditions, etc. Now you can start with genetic modification to try to increase the yield, and we might succeed in that. But with every genetic modification, and some literature points to that, especially from potato researcher, with every modification, you get 4 new problems that we did not oversee yet. Now, before we start with genetic modification, shouldn't we learn to feed plants properly? Shouldn't we start with that? To feed them properly and to make them truly healthy. That is something that I would really prefer over any other technique. But as long as we think that plants live on 17 elements, like I said a few weeks before, we cannot expect them to grow healthy. One of these building blocks in health are amino acids. They're the organic compounds and they form the basis of every biological molecule. They're the bricks that build cells. So we can put all kinds of fertilizers to the plants, but they can produce some amino acids, but they need amino acids from other organisms in order to be fed properly. And there's so many hundreds of amino acids. But in plants, there is a few that are really, really important. And like you could see on the previous list, there's around 15 or so that are really important, but they don't have the same importance. You have amino acids that you need very, very small amounts of, and you need, of course, amino acids in larger amounts. If you look at the list of amino acids in plants, usually you will find in the left column, you will find the plant-based amino acids, but many amino acids on the market are made from slaughter waste, hides from cows, etc. And these contain 2 amino acids that you don't want in plants. They block other amino acids to enter that plant and to work in that plant. So I'm not saying the latter amino acids are really bad, but I'm saying clearly that plant-based amino acids are better because you won't have these hydroxyproline and hydroxyxyline in it. So if you talk about animal-based products, they're usually chemically hydrolyzed, and some amino acids are destroyed, etc. And publications in Nature are that these two, hydroxyproline, will be antagonistic on your plants. And if you look how most aminoacids are derived and hydrolyzed from animal collagen, from hides and leather production. I took this picture in India one day. That's not the way we want to feed our plants, in my opinion. We made many comparisons, and of course I'm advertising for our own products because we care for plants. Our liquid fertilizer, plant-based fertilizer, contains 190 grams of amino acids. That is really something that helps plant stay healthy. And that's why we really want to emphasize on the difference between organic farming and organic fertilizing versus synthetic fertilizing. With synthetic fertilizing, you bring 17 elements maximum. But like I said a few weeks ago, plants need at least 30, and we don't even know what we don't know. This is the status quo for science at this moment. But if you have free amino acids in your plants, you're actually inviting insects and fungi. If you have, and this is published already in the 80s, the free amino acids are really calling for diseases. Nitrates. Most chemical fertilizers contain nitrates, and these nitrates are inviting diseases because they produce simple sugars, and simple sugars call for, that's a plant system of calling the diseases in. Complex sugars keep the plant strong, and the exudates from the roots into the soil are, if these sugars are complex, they feed a certain range of bacteria and fungi, but they won't feed what we call the pathogens, because high quality sugars means that plant is of a high quality. And fungi and insects, they don't bother to attack that plant. It's too much. Glutamic acid, for instance, is really essential in plants because it helps to transform the nitrogen into a protein. And therefore it's essential. So you will have the green leaves. Anybody? Okay. It is important for chlorophyll photosynthesis, really important and crucial for conversion of anorganic nitrogen to proteins. That is a total different approach than any fertilizing theory that we have until today, where we say we give anorganic fertilizer to the plant so it can be absorbed by the plant through ionic exchange and osmotic pressure right away. But that's infusing anorganics to the plant, where plants really need organic matter that is transformed into anorganic matter by amino acids and by bacteria and by fungi. These are the real true partners of plants. And that's not the salt that we give them. So in order to be able to help farmers to create a healthy soil, we produced a product. It's called Terra Pulse, and time is almost over. Terra Pulse is made of a few products: the humified grape mark. It's rich in bacteria, fungi, and streptomycetes. They're really good in transforming the soil. Fulvic is a very important step, I must say, a very important step in producing a natural soil, because fulvic is derived from humic acids. But the soils today, agricultural soils, they're not able to produce humic acids anymore, simply because the cycles are too short. Compost does not contain humus, etc. So this fulvic dry that we have is literally from natural fulvic acids that are derived from drinking water in the Netherlands. If you go to our website or the Vega website, you will find information on the fulvics. Really important to change soils and soil behavior. And then we have rock dust. Rock dust are basically, that's fresh soil. All our soils are from volcanic and mountain activity, and they're all worn out minerals, and we don't know what we have been using. We don't know how many minerals we took from the soil during the course of our agricultural systems. We don't know what we don't know. So as a pure measurement, we bring in fresh minerals that we never heard about. Germanium, lanthanum, cerium, etc., because they're there, and we still don't know exactly what plants do with it, but it adds up to the minerals that we already give. And it contains of clay particles to increase the carbon exchange. What does it bring you? What does it bring to the soil? It contains a huge amount of energy. That's 10,000 megajoule per kilogram. If you have these energy drinks that you now have on the market, like I don't know the names, but all kind of energy drinks, they have energy levels up to 2,000 megajoule per liter. And our Terra Pulse is very active. It contains 10,000 megajoule per kilogram. That's really, really good. And it's simple to apply. You can use it anywhere. It's used on sport fields. It's used in nature rebuilding. And it has a very, very nice CN ratio. That means it is up to decomposing by bacteria. You apply it in a certain amount. And we have done the research. And I just want to show you a few things here in the Terra Pulse, in potatoes. Just check the green dots here, average weight. That's 13% difference, and a 35% difference in the bigger sizes of potatoes. So that's, for potato farmers, that's really important data, and this pays for the Terra Pulse. And at the same time, it increases the soil quality for the next harvest. When you work at the soil, you shouldn't be thinking in 1 year. You have to think in a number of years. Most farmers, however, they think per year. Maybe they rent different land next year. Maybe they will grow other products next year. But anyway, most farmers think per year, and we shouldn't be doing that, because soil is something that we need forever. We have another farmer's trial where we have, and I can show them, this is prior and this is after applying TerraPulse 1 year later. So the organic carbon rose from almost nothing to 3.3%. The CEC, cation exchange capacity, raised. The saturation was lowered. That improves the CN ratio. The total amount of nitrogen was increased, and the mycorrhizal colonization was more than doubled in 1 year time. And for grass, this was really, really, really important for dairy grass. So changing your soil will also change your animal feed, because it will change the contents of the plants. And since we did a lot in nurseries and tree nurseries and plant nurseries, you can see the difference. A lot greener plant, more compact. And this is nitrogen growing. This has a very light root system, very healthy, compacted root system, where you have more long roots here, lighter plants. And what it does to the soil, and actually we can see that through our digital microscopes, very precise. You can actually see the difference in soil structure within 1 year. Within 1 year, you create the soil from this to this, a soil that holds on to water. It holds on to the minerals. They don't leach out. So actually, we see results from a better soil care, means better taking care of the plants, means healthier plants, because they get the food they really need to grow healthy. With this, I want to close off, and I will be more than happy to answer your questions or react on your suggestions, and I will give the microphone to Jortur. Thank you.
Thank you, Pius, for a very full and detailed explanation on how to avoid the plant disease. We are a little bit behind time, like you mentioned, but we will still open the floor for some important questions if there are any. So you can type them in the chat or question from Gigi. Do you see them, Pius? Would it be beneficial to add the rock dust to compost? It's the first question.
Frankly, yes, because the compost, we don't know where the compost came from. Was it from a very good, healthy soil? Was it from a garden, an old park? So rock dust is not expensive. So I would do it. I would do it.
Good.
And to be more complete in this answer, we don't know what is missing, because not a laboratory in the world until today is able to, well, they're able to, but it's very costly, to analyze the minerals that we don't mention in the fertilizing principles until today. It will change, but it will take time. And in the meantime, yes, put rock dust or the ashes from your wood fire. If you burn clean wood in your in your wood fires, then use that ash because it contains all the minerals that the plants, that these trees took from the soil during their lifetime, and you will give it back to the soil. And ash is for free. I guess many people have wood fires on Iceland, or not so much, maybe, I don't know.
Good, so you answered the question from Eglo as well. You can ask question in Icelandic also if you'd like. 10-15 seconds.
We have a delay here.
Okay, I don't see any other questions, so we will then continue and go through what is ahead for us in presentations, both from you and also one in Iceland. If you go forward, Piers.
Oh, I hit the wrong button again, I guess.
Mm-hmm. JJ has one other question, if you can see that. Sand has been used for gardening. Is it the mineral content or the soil structure that is helpful? Is the question.
Can you repeat the question?
Sand has been used for gardening. Is it the mineral content or the soil structure that is helpful when using sand? Is it the minerals or the soil structure?
It's both. It's both. If you use sand, may I ask, is this on a clay soil or on what type of soil would you use the sand? Maybe I don't understand the question.
Yes, and for example, on carrots, when growing carrots.
Well, sand contains, of course, okay, for carrots, sand contains minerals, but we don't know which ones. And in order to bind that sand, and now is my, I don't know what happened, but I did it again.
Just continue, Piers. I remember the last slides.
Okay,
oh, there you go.
This is here a sandy sand, a sandy soil. If you get some clay particles in it, or even if it's sand, and you get some organic matter here, then you will have an aggregated soil where you can grow carrots without the risk of all your minerals leaching out. We have customers in Scotland, in the north of Scotland, with sandy soils, and we can see there's things really changing. Organic carrots growing on very sandy soils, and the minerals are held on to because they hardly fertilize anything on these carrots, and the sand is able to hold on to the minerals. So you have basically this picture. So for the carrots, this soil on the right hand would be better than this one because it contains more oxygen, which is really important for carrot production. Next question, if you have one.
There are no questions coming up. So if you could browse through the last slide, please, to tell people what the upcoming webinars. This is the next one will be after 2 weeks, tree planting and growing trees, everything about them.
Yeah, this is going to be fun.
It's going to be fun. Good to hear.
Because it's, I promise you, you will see things that you have never seen in any course or book when it comes to trees. And tree biology is my background.
Yeah.
And some of the pictures that I will use are more than 30 years old and are still not used in practice. It's amazing. Amazing how much money is lost by planting trees and shrubs in a total wrong way. So
Will be interesting. The next one after that. This will be about agriculture.
Yeah,
in 1 month time. Yeah.
So that's how your crop can help you to make healthy soils. So we have our motto, we grow soil, but basically we help plants to grow soil because plants are the only soil producers in the world. Carbon in the soil is one issue that we will talk about, how to bring carbon in the soil and how can you stick to that carbon, because most carbon is leached out again. We'll come back to that. Okay. Foliar feeding, that's actually one of my hobbies, because I think foliar feeding is really essential for healthy plants. And trends in environmental legislations, this is for the more the theoretical people. What can we see, what is changing in the world when it comes to the use of chemical fertilizers and pesticides? I'll give you an overview of what's going on in the world of these legislations. And I don't know what this is.
There is an upcoming seminar this Thursday here in Iceland, which I think will be very interesting to this audience. So I'd just like to mention that it will be broadcasted through Bændablaðið, BBL. I'd like to mention that. A lot of interesting topics on the agenda there. Okay.
It's in Icelandic, I assume.
Yeah.
And what is it about?
It's about organic
farming. The questions.
No, it's basically about what we are doing, organic growing, environmental.
Okay. Oh, you're freezing again. I hope it's not really cold on Iceland. You are frozen. There you are again.
Yeah.
So
I'm in the countryside, so I have an unstable connection. So just at the end, our websites, vg.is, and next one, your website, and next one.
Then across the English one.
Yeah. And then here's our Facebook page, and we have a YouTube channel now, which you can find there. And we put our recordings of these sessions up there. So that's it. Thank you, Pius. Thank you all for attending.
Thank you all for attending. Thank you for listening. It's been an honor to be on Iceland again. Thank you very, very much.
See you in 2 weeks. Thank you.
See you again. Take care. Bye-bye.
Bye-bye.